All right, what we're going to do now is in our solarcoffee.web project, we'll head down into our startup class, and then we're going to make some changes to our configure services method to actually set up our DB context that we've been working on in the data layer to connect to the Postgres database that we'd like to use for this particular project. So we already have services.addControllers in our configure services method, and now what I'm going to do is add a line here for services.addDBContext, and we'll need to actually provide our SolarDB context here as the type. We'll have to make some imports here. So first of all, we can reference solarcoffee.data and use solarcoffee.data.solardbcontext. If you don't have the key binding there to do that, then if we right click on the project here, we should be able to add a reference. So we'll click add a reference, and we're essentially referencing our data project so that it's accessible within the web project here. I'm just going to use the key binding here. And now we also need to specify some options here, for instance, our connection strings. And this is actually going to be pretty simple. We can use a lambda here, and so we'll just call it opts, and then on this opts object we have, for instance, enable detailed errors. We'll leave this on for now. That could be potentially useful. And then we're going to say ops.use npg-SQL. And this actually takes a configuration, which would be our connection string. And rather than hard code our connection string here in the startup class, we really want to get this from our configuration. And so I'm going to call our connection string here solar.dev. Now, if you recall, a few videos back, we talked about this appsettings.json and appsettings.development.json files. And so what I'm going to do is edit this appsettings.development.json, and we're going to add a key to our JSON file here for connection strings. So go ahead and add that here. We will need to make sure that this is properly formatted as JSON, and I said we'd call this solar.dev. And now we just need to provide a Postgres compatible connection string, and in our case it's going to look like this. We're going to run the database on localhost in dev. The default port for Postgres is 5432. We'll create a couple of extra parameters here in a moment, but let's go ahead and call our username solardev. We'll make the password solar123, and the database we'll call solardev. Oops. And make sure that you have a semicolon here at the end of the connection string. If your connection string doesn't look like this, and if you have a typo somewhere or you're missing things like semicolons, then you will have trouble connecting to your Postgres instance. Okay, so we have this key connection strings. We've got a key and an object under that called solar.dev. And so when we're calling configuration.getConnectionString, that's actually just going to look for a key called connection strings and then look for the solar.dev key here, and it will resolve to the connection string that we have here. So now I'm going to open up a terminal and use the PSQL CLI tool to actually generate a user and a password and the database solardev. So let's go ahead and do that. So our web server isn't running, and I'm going to run the command psql here. And now we're going to create a new user on our Postgres database. You may be connected to your Postgres instance with a different username. It might be Postgres, or it might be whatever you have currently set up. we're just going to run a command to actually create a new user that corresponds to the user that our connection string is expecting here, which is this Solar Dev user with password solar123. And the command that we'll run for that is create user Solar Dev with password solardev123, or I think I called it solar123. And then a semicolon here, and then the output we'll get is create role. And then what we're going to do is create database, and I called our database solardev. And you can see the output we get is create database. And then I'm going to run the command grant all privileges on database solardev to user solardev. Oops, and it's not to user, it's to solardev. Okay, so grant all privileges on database solardev to solardev. Now we can actually change users from whatever user you're currently on to solardev with the shortcut \C, and I'm going to say solardev and then space solardev. So this is saying change to the database solardev as user solardev. And it should say you're now connected to the database solardev as user solardev. Okay, if that's working, then we're actually ready to take the next step, which is to start connecting our web application to the database that we just created. So I'm going to head back over here. I also realized that my text is quite small, so I'm going to bump the size up here. Okay, and let's head back into our startup class. So we should have this add DB context of type SolarDB context with the options configured to enable detailed errors and to use Postgres here via the use PostgreSQL. So what we're going to do now is, first of all, we can disconnect from our database with Control-D here or \Q. And now I'm going to run some entity framework commands to actually create our first migration. And while we're in the project, we need to go ahead and add some more NuGet packages here to enable entity framework to work with migrations to our database. So what we need to do is look for a NuGet package called Microsoft.entityFrameworkCore.design. And I'm going to go ahead and add this to our project. Again, if you're working from the terminal, just follow the instructions for using the .NET command to install NuGet packages that you can find on nuget.org. I'm also going to add Microsoft.entityFrameworkCore.tools. So in our list of dependencies here for packages, I can see that I've added Entity Framework Core Design and Tools. I'm also going to go ahead and add the base Microsoft Entity Framework Core, which should be added to our web project. And I'm going to add another project while we're in here for working with JSON. And the most popular project in the .NET ecosystem for that is Newtonsoft JSON. So we should be able to find Microsoft.ASP.NetCore.MVC.Newtonsoft JSON. This is going to provide us with some tools for things like formatting and serializing the JSON responses that we're working with in our web API. And likewise, there is the base Newtonsoft.json project, which I'm going to add to the project as well. Okay, with that added, we can actually head back to the terminal and we'll run the commands to create our first migration. So to make this work, we actually need to change directories into our data project. Remember, this is the project that's actually connecting to our database, and then we need to run this command .NET EF. We'll pass it this flag startup project, and then we'll point that to our web project. So from here we'd go up a directory into solarcoffee.web, and then we run the command migrations, add, and then a name for the migration, which I'm just going to call initial migration here. Once that's complete, you should see done here. If you do get errors when you try to run this command, again, make sure that you're trying to run it from the data project, and that for the flag startup project, we're pointing to our web project, and that you have the various packages that we went through and installed here, installed in the web project. So what this has done is in our data project now, you should see a directory called migrations, and in this we have some auto-generated code which actually runs commands using this migration builder object, which does things like creates tables for us, and you can see that it's creating some of our identity tables. We're also creating various indexes on these. And then we have this snapshot file. So we don't need to worry about really editing anything in these migrations yet, although it is totally possible to manually edit these files depending on your specific needs. But for the duration of this project, we're really just going to be using the migrations that Entity Framework Core builds for us, and it's actually kind of a nice utility. It would be a pretty long process and potentially more error prone to actually create any of these migrations by hand. So now to actually run the migrations, we have to run another command. Again, we run this startup project flag using .NET EF, solarcoffee.web, and we need to run the command database update. So now what's happening is the Entity Framework Core is going to be looking in our web project, and it looks like we have an error here, so we'll go ahead and update that in just a moment. But what it should be doing is looking at our connection string and actually connecting to the instance of Postgres and then updating our tables. So since we have an argument exception here, keyword not supported, password, solar123, database, all right, let's go ahead and fix that. And the problem is we have a colon here instead of an equal sign. So just like I mentioned, if you mess up the syntax for the connection string here, it's very unforgiving, as it should be, and I had a typo here. Make sure that anytime we have this sort of key value pair syntax separated by semicolons, that we are associating keys with values using the equal sign and not a colon. So if we head back to our terminal now and I run the same command again, we should have no problems. And you can see that it says done. And what this has actually done now, as I mentioned, is it's connected to our database, run those migrations that are defined in code, and created the various tables and relations in our SQL database for us. If we want to take a look at it from pSQL, then we can just go straight in. And again, I'm going to change users to solardev. And if I run the command \dt, this is actually going to give us a list of our relations. We can see a number of tables here which are related to Entity Framework identity, which gives us things like users and roles and user claims out of the box. We also have the tables that we've created here, or models that we've defined, and then Entity Framework has created tables for us in customers and customer addresses. There's also this sort of table containing metadata about migrations history, which starts with a double underscore. Entity Framework is also managing that table for us. So if I select star from customer addresses. Now, one thing to keep in mind with Postgres anyway, and SQL in general, that if we don't surround our table names with double quotes here, it's actually just going to interpret that as case-insensitive customer addresses, and it will say it won't find the relation. So if we surround it in quotes and use the proper casing here, then we should be able to select from our table. Now, obviously, we don't have any data in this yet, but just to take a look at the types of tables it constructed, let's select star from customers here. And if you take a look at what's going on here, we have our customer table, which has a column for all the properties we created, plus this column primary address ID. And there's a foreign key from primary address ID here to customer addresses ID. And so that's kind of how we establish the relationships. Again, if you recall back in our data models, customer here has this customer address type on it, and so Entity Framework has done the work to create that foreign key relationship and the data layer as you see here. All right, in the next video, we're going to go through and actually complete the definition of the models in our data layer.